Amazing. Okay. So, hello everyone. Welcome to my talk, Best Practices for Developing Amazing Kotlin Multiplatform Apps. So perhaps you've heard of Kotlin Multiplatform before, or maybe not, and you're wondering why would you want to use this technology? Well, Kotlin Multiplatform is an SDK by JetBrains, and it went into beta in October 2022, and it's going stable soon. And it allows development teams to share common code between platforms. Now, I want to highlight these two terms, common code and platforms. What is common code? What can we share? And what platforms are supported by this technology? Well, it's server, mobile, which includes Android and iOS, desktop, which is macOS, Linux, and Windows, and web, which is JS and WASM. Now, before we had Kotlin Multiplatform, whenever we wanted to develop, say, an Android and iOS, maybe a desktop app, we would always have to create the full layer of data and core business domain presentation and UI layers for Android, and then the same for iOS. So there was no code sharing whatsoever. But with Kotlin Multiplatform, we can have this shared layer of, and that's that purple layer of the data and core and the business and domain layer that's shared between Android and iOS. And we can then we only have to write the presentation and UI layers natively, so for Android and for iOS. But we can take it one step further and also share the presentation layer of presenters, view models, and controllers, and then do the UI or the views natively for Android and iOS. But with Compose Multiplatform, we can even share the UI layer. So the only thing that's kind of left is the platform-specific code, and that's something that we can't share. So how does it actually work? So Kotlin Multiplatform will compile your shared module into platform-specific artifacts, which it then adds, which you then add and use in your application. So on the left-hand side for iOS, the Kotlin native compiler will compile your shared module into a framework file or a CocoaPod, which you then add and use in your iOS app. On the right-hand side for Android, the Kotlin JVM compiler will compile your shared module into jar files or AAR files, which you then add and use from your Android app. So what are the benefits of this approach? Firstly, it's about flexibility to choose what is shared and what is not shared. So you can decide, I only want to share a constant, or I only want to share like a utility function, or I want to share a whole feature, or even the whole application almost. The choice is really yours. Then you can choose to share in a new or an existing project. You don't have to start every project, every Kotlin Multiplatform project from scratch. You can start today in your current project. The shared code also means that there's less duplication, and this automatically will lower the effort and costs per feature, but it also ensures consistency among platforms. So for example, if you have a constant that you're sharing between Android and iOS and desktop, maybe it's your sales rate or your sales tax or something like that, and then you can share it amongst those platforms, and it will always be consistent amongst your platforms. And you can access platform capabilities without overhead. So you can access your platform APIs without overhead. So I want to show you a demo. So I'm going to go into Android Studio, and this is my sample application that I'll give you my GitHub repo URL a little bit later, but this is the application that we're going to go through right now. And first I'm going to run the Android application. You can see at the bottom here, Gradle is running, and I'm going to zoom in. You can see it says Hello World, and then when I click on it, it animates the compose icon in, and it says Hello Android 33. Now, 33 is the SDK version of the Android device that I'm running on at the moment. And as I click on the button, it animates in and out. Now, I've also created it so that it can run on desktop. So here's me running it on desktop, and there we go. So we have Hello World, and it says Hello Mac OS X. And again, the animation. Then we can also run it on iOS. This takes a little bit longer, but there we go. Hello world, hello iOS 17.01. And it animates in and out. Great. Right. So now I want to show you just how this works. So we've got our project structure here, and I just want to walk you through the project structure just quickly. So we have our Android application in Android app, our iOS application in iOS app, and then we have this shared module where all our code, where some of our shared code lives. So we have 4 directories in here, or source sets. Now, the most important one is this common main, and that's where all our shared code lives. Then we have 3 other source sets, Android main, desktop main, and iOS main, and that is where our platform-specific code lives. But I want to focus right now on common main, and I'm going to show you a file called app.kt. Okay. So we've got this function, and that is our application function. It is a composable function called app, and inside of it, we wrap a material theme around some content. Now, first we declare a greeting text and a show image, two variables, greeting text, which is initially hello world. And remember, we've created an observable and we're remembering it as we're good Compose citizens. And then we also have a show image variable that is initially false. So we then have a vertical structure or column that has a button and an image, and the button has the text, greeting text inside. So initially it's hello world, but when I go and I click on this button, we execute the following code. And you'll see that we changed the greeting text to hello, get platform name, and the show image we toggle. So it will cause the next piece of code to toggle in and out. It's that animated visibility side effect that we're running, the animation. And that will animate in and out an image with the icon for Compose Multiplatform. Now, if you were being particularly astute today, you can see that we have this get platform name, but it's different on every platform. So I want to explain to you exactly why that is. So let's go to that function. So here we see we have expect fun, get platform name, and it returns something of type string, but no implementation. Just this keyword that is going to give us a clue called expect. Now, if I want to see the behavior, so this part of the code, the common main, is defining the declaration of the behavior that we're expecting to see. But we're going to implement the actual behavior in the platform-specific source sets. So that would be Android main, desktop main, and iOS main. Now, the easiest way to navigate to those functions that match this get platform name is by clicking on the cursor icon. And we're going to click on, so there are 3 different implementations, just as there are 3 platforms supported. And the bottom one is for Android. So here we are, and we're actually, if we use this select open file, we can see we're in Android main. And we have the function signature is very much the same as it is for in the expect case. But instead of saying expect, it has actual as a keyword in front of it. So they kind of match. You have your expect in your common main, and you have actual in your Android, desktop, and iOS main. And then we have this implementation of the behavior, the expected behavior in there. So then we're going to return Android and then some Android-specific code. So here we're returning the SDK. Remember, we were returning 33, and this is the way that you do that on how you retrieve that value on Android, and that is using Android OS build version SDK in it. Let's navigate back to expect, and let's see how we do desktop next. So desktop, we can actually go ahead and use some JVM stuff. We can use system.getProperty, and then we can use OS name. And that will actually get us the Mac OS X. Next, we can go back and we can see what's happening in iOS. So here we can see that we're using a UI device, current device system name, and system version. So here what we're doing is we're actually using UIKit to get our current device, to get the system name and system version, to populate that get platform name so that we can get iOS. So on an iPad, it would say iPad, and it would say iOS and then 1701. So that is how you get the platform name. So what did we just see? Well, we saw how we could actually get a platform name from our common source set. So we have a lot of common code, and then we can customize the platform specific stuff using the expect and actual function. So let's go back to my slides, and then I'll show you the rest. There we go. Okay, so if you want to follow along with this code or have a look at what I did, you can find it on pahill/cm-demo. But if you are keen on trying this for yourself from scratch, you can go to jb.gg/compose. And this is where you would actually land up. You would land up on the Compose Multiplatform website. You can click on Get Started. And then you have a sort of like a menu of options to choose from. It's like a little box of chocolates. You can choose to share code with iOS. So this is Android and iOS. There's desktop, which is Windows, Mac OS, and Linux, and web, and this is the WASM one. So then you can click on iOS, as I did. You can say, use this template, create new repository, and you can just enter your repository name, click on create repository, and voila, there is your copy of the Android iOS template, and it will share code between Android and iOS using the regular framework files, so no CocoaPods as it used to have. So now that we've sort of introduced the expect actual mechanism, I want to give you a few best practices for using expect actual. And my first best practice is really to not. First, check if there's a suitable Kotlin multiplatform library that's already doing it for you. And perhaps you're wondering, like, where do you find these libraries? Like, I don't know where to find them. So this is a really great place to go looking for them. It is called KMP-Awesome, and it is by my colleague Kostya. And he's curated a list of really an amazing list of libraries, and he really looks at each library and checks whether it's a good quality library and so on. And it's very extensive. It's got a lot of. It will indicate what platforms are supported, what the differences are between the libraries, and these are just the categories. They're not the libraries themselves. So each of these little categories also has many links underneath into different categories, to different libraries. But if you must use expect actual, you can use expect actual functions. So here we have a expect fun. I hope you expect fun. A random UID that returns something of type string in common main. So this whole block is our shared module, and then we have common main where our shared code lives, and our common shared code lives, and then we have iOS main and Android main where our platform specific code lives. So in the common main, we have to declare our expect functions, and that is the declarations that we expect to see in the Android main, in the iOS main, the platform specific source sets that we've defined. So then we can see here on the side, we have for Android, we're actually using Kotlin JVM. So we can use anything that is Android libraries that we want to use, or JVM libraries that we want to use, we can use from Android main. So here we've actually defined a function called, or we're implementing this function with something from java.util using a UID, random UID, and then we toString that to get a nice string. On the iOS side, on the left-hand side, we can use Kotlin Native and most of the Apple libraries, so Foundation, Metal, and so on. And you can also use a very similar mechanism to get to Cocoa dependencies and so on. And here we're using Platform Foundation to get NSUID UID string. And that is how you basically get the different behaviors on different platforms. So I just want to reiterate, because this is super, super important. In Common Main, you can only use Common Kotlin. Now, what is Common Kotlin? It is either a Kotlin language feature, something from a standard library, or a multi-platform library. Then in Android Main, you can use Kotlin JVM and any Android dependency, but you can't use iOS dependencies from Android, and you can't use Android dependencies from iOS. So in iOS main, you can use Kotlin native and any kind of Apple API. And that is sort of how they all differ. My hot tip number 2 is to use expect actual functions and properties for simple cases, and to use interfaces for more complex cases. So here I'm going to illustrate how to use interfaces. Say that we're going to use a very similar scenario to what we had before with our platform names. So here we have an interface platform that has a property called name. And then on the Android side, we're going to have a class that implements this platform called Android platform. And on iOS side, we're going to have an iOS platform class that implements platform. So, and it will that, and on each side, on Android side and iOS side, it will do it in a platform specific way. But how are you going to provide that platform interface implementation? Well, you can use a factory function. So here we expect funding a get platform function that returns something of type platform. And then on Android, we just return Android platform. And on iOS main, we return iOS platforms. So that's a factory function approach. Then you can also use early entry points. So you can define a function called app that you pass a parameter to of type platform, and then you perform certain app logic on it. So on Android, you would use this app function on create for your application, and then you would pass Android platform to it when you use it. Then on iOS side, this is a Swift UI application, and in the init function, you would call app with iOS platform. You can also use dependency injection frameworks to provide interface implementations. This also obviously makes it so much easier to do testing in a nicer way. So here I'm showing you how to do it with Coin. You can have an expect property called platform module of type module. On Android, you will sort of implement that property platform module with, you will say, actual val platform module. And then you use a very nice little DSL from Coin to define a module. Now, single, and then the braces platform, and then the implementation means that we are going to have a singleton. And whenever we inject something of type platform, please give me a singleton of type Android platform. And similarly, on iOS side, whenever I ask for whenever I inject something of type platform, please give me a singleton of type iOS platform. So I often get asked, can I use Dagger or Hilt with Kotlin Multiplatform? And the answer is no, because they are not multi-platform libraries. They're very Android specific. You can, however, use Coin, Codeine, and Kotlin Inject. Or if you're super brave and really keen, you can also use manual dependency injection. Next, I want to talk about coroutines and flows. So coroutines have been first, I'm going to talk about coroutines, which of course is very closely, which is also closely associated with suspend functions. And this is the demo that we're going to be looking at. So here we have a demo from the JetBrains site. It's a tutorial that basically gets data from a web service, from the SpaceX rocket launch web service, and it will get data and then display it on the screen for you. But of course, getting data from a web service is a potentially long-running operation, and so it needs to be done in an asynchronous way. And so that web service call, in this case, I was using Ktor HTTP client. That call always needs to be done or needs to be marked as a suspend function. So how do we actually go ahead and consume these functions from Android and iOS? And I'm going to focus very lightly on Android with more emphasis on iOS because that's where the tricky part lies. So for Android, if you're using Compose, you can use the launched effect side effect. So this stk.getLaunches is your suspend function, as you can see the gutter icon over here. And you're using a launched effect side effect to sort of wrap your suspend function call, and then you're setting a variable to that the result of that function call. Now, when that list rocket launch actually gets a value, that will cause the recomposition of this composable function pull to refresh rocket launches, which consists of a pull to refresh control and a lazy list of rocket launches. So that will populate the whole rocket list, rocket launches list. Now, on iOS, things are definitely a lot more tricky. This is because on iOS, there isn't actually suspend functions. And it's not an iOS a Swift or Objective-C concept. So in Objective-C headers, they are represented as a completion handler or a callback. So how do we actually go ahead and handle this in a nice way? Well, the first approach is the simplest approach, and that is to actually have a completion handler. So this is the way that it's going to work. You have stk.getLaunches, and then you pass the completion handler into it. Now, maybe just to give a little step back, you see there's that self.launches variable. Now, that's a published variable, and it is going to be displayed on the screen. And it has three possible states. It will be loading, result, or error. So depending on the state and depending on the contents of that state, so if it's the result state, there might be some launches inside of it. Depending on the state of that self.launches, your screen will be updated. So if there's some launch data that comes through in your completion handler, you will set that published variable to a result enum. But if there's an error, you will set it to an error enum with a nice message. However, this is definitely not the best solution. The reason why I say that is it doesn't read really well. It's going to be very, very difficult to actually reason about if you start nesting your suspend functions. It will quickly descend into callback hell. And so this also doesn't support cancellation. So if you call, there's no way to call stk.getLaunches.cancel or some other kind of thing. You either have to wait for a timeout or the results to come back. And that's a really bad use of limited system resources. So what can you do instead? Well, your second approach, your first approach to solving that approach is to use async await. Now, the first thing that you need to know about async await is that it's from Swift 5.5 in iOS 13 onward. And the first thing that you need to do is you have to mark your view model with @main actor. Now that will ensure that your code is run on the main thread. And that is because calling suspend functions must always happen on the main thread. That's a Kotlin native requirement. Then you wrap your code in a task to support concurrency. And then you can use the await part of the async await mechanism to get your launches. And then when you get your launches, you can set the result or you can set an error if you maybe catch an error. So there is a problem with this, and the problem is that you can use task to get a handle, and you can call cancel on it, but it doesn't actually do anything. It's just the stub. So that is a big problem, and this approach doesn't actually have any cancellation support. And that's a problem because, again, the limited system resources. So how do we actually provide cancellation support? So my next approach is to use a library called KMP Native Coroutines from Rick Kleffers. Now, this is a sort of like a plugin and library that you configure. So you need to do some Gradle configuration. And then also you have to do some Gradle configuration. And then you have to mark your suspend function with an annotation @native coroutines. Then you need to wrap this suspend function call in an async function. And that will allow you to actually not only get the task handle, you could get that before, but you can call cancel and it will actually cancel. It won't just sit there and blink at you. So this will actually support cancellation. Again, it's important to set that main actor on your view model, just because you will get a really big error if you don't. So the next approach that you can try, if you don't quite like that approach or you have some other requirements, is to try and use TouchLab's new Sky library. So all that you have to do really is to configure the Sky Gradle plugin, and then your code pretty much looks the same as it did with the async await implementation. So the async await implementation didn't have that @native coroutines that KMP native coroutines had, and similarly, it also doesn't require like a wrapper function. And again, you can call task cancel on it, and it will actually cancel. But and again, remember to do your @main actor like a good citizen. Next, I want to talk about flows. And flows, if you haven't heard about it, is just a sequence, as a way to have a sequence of emissions of values, instead of with a suspend function where you return just one value. Now, the problem with flows is, of course, or a flow is, of course, that you have you obviously have to have Android and iOS support, but what I'm trying to illustrate here is just another application where we have so this application that I wrote over here is just a application that returns that whole list, but sort of makes it like step by step, like different rocket launches all at a time. So it looks like time is progressing. So here you can see it. So now it just shows one, it shows the oldest one, then the second oldest one, and so it grows. The newest one will always be at the top, and it kind of just scrolls on like that. So that's what this is illustrating it, and it's implemented as a flow. So that stk.get launches is a flow. So in iOS, we have a couple of problems with flows. Firstly, Objective-C doesn't support generics on protocols. And so the flow interfaces, now interfaces and protocols are sort of, interfaces are mapped to protocols in Objective-C. They lose their generic value type, and that's a big problem. So you also, because you're going to lose your type safety, you also need to still have cancellation support and main thread safety. So do not fear, we have KMP native coroutines to help us with this. So again, you would have to mark your flow functions with so that get launches function with @native coroutines. And then instead of using async function, you would use async sequence. And then you would iterate over that sequence with the await mechanism and continually sort of just update that published variable with the results of that, of the latest result of that sequence. Again, main actor, very important. With Sky, you can do something similar. In Sky, the flow is actually translated almost translated into an async sequence. That's a Swift concept, and so you can get it as normal, but there's no do, catch, try. There's just a for await that you're going to run. So you're going to iterate over the data in the sequence, and you're going to assign values to that launches published variable. So what approach should you choose? Should you use KMP native coroutines or should you use Sky? So KMP native coroutines is a tried and tested solution. It's been around for a while, and it may be more stable than Sky. It also supports async await, combine, and RX Swift approaches. So if your application, your iOS application already perhaps uses combine, then maybe KMP native coroutines is a better solution for you. Sky is less verbose. In general, you don't really add wrappers or anything like that. But it is also it is quite new. So there are a few bugs in the system at the moment, but nothing to worry about too much. But Sky is also interesting because it's not just about coroutines and flows. It also has support for other Swift interop issues like enums and default arguments and so on. It's actually a very good library to check out if you want to improve your Swift interop. But the surprise of it all is that you can actually use both together. You can use Sky and you can use, say your iOS application needs combine. You can use Sky and KMP native coroutines together. It's not not the one or the other. You can use them as you like. So my call to action is really for you to go and try the Compose the little Compose template that we have. Go investigate it, go see if you can figure out how it ticks and how it works, and give it a try. Create a wonderful application and send it to us so that we can feature it on our page and you can become famous. Wouldn't that be amazing? All right. And that's it for me. Thank you. Stay in touch. I am on X/Twitter, and I also have a blog. I am also on the Kotlin Lang Slack if you need me. And with that, thank you. Are there any questions?
I think you did a great session, Pamela. Thanks about that.
Oh, great.
I learned about new keywords. Now we can get the question. We have the first question from Simon Top. He asked, I want to ask you something. Do we have a good way to handle translated literals from the common main inside the Compose multi-platform function?
I'm not sure if that means translated string literals. I assume that that's what it means. So there is a library called KMP, it's Moko Resources, and they support string translation in quite an extensive way. So they use things like plurals and things like that. So that is definitely a library to go check out if you're concerned about translations and using translations in your Compose multi-platform and Kotlin multi-platform application.
Great. We have another question. It's from also Simon Top. He asking if you know it's possible to use Coin or any other DIs for JavaScript or desktop apps too.
It's a very good question. I'm not 100% sure, but I'm sure that I can find out the answer for you and I'll tweet it out a little bit later.
Great. The last one is from also Simon Top. He's asking if we use main actor and do the coroutines calls in the main thread, will the network code not block by the main thread? Great question.
That's a very good question. So remember that the network calls are suspend functions. And so, no, they will not block the main thread. They're just called on the main thread. And then the call will be suspended. So no worries.
Great. I think we don't have any questions. Thank you, Pamela. It was a great session. And of
You're
course,
welcome.
we will try to use new Kotlin multi-platform. Thank you. Also, where
Thank
to
you.
get the links? We need the presentation.
Sorry?
We need the presentation for the link. Can
Oh, the
we?
presentation, the
Yes.
presentation. Um, I will definitely post it on my Twitter account. It's just Pamela A. Hill, and you can find it there.
Okay. Thank you, Pamela. Thank you.
Thanks.